Hello and welcome to this video, Unit 2, Lesson 3, Truth Tables. We are going to use truth tables to explore what conditions will make a statement to be true or false. So under what conditions will the conditional statement be true or false? That's a lot of use of the word conditions in one sentence. So the most basic truth table is the one for the statement P implies Q, or if P, some event, we don't know what P stands for, could be anything, then Q. An if-then conditional statement. All right, so we know that a conditional statement is only able to be proven false if the hypothesis happens and the conclusion does not follow. So, for example, the statement, if it is raining, then the ground gets wet. The only time that would be a true statement is if it rains outside and then we see the ground does not get wet. Then that statement would be considered false. That would be the only time it would be false. I'm going to write down what this stands for. If it's raining, then the ground gets wet. Okay. In all other cases, we would consider the statement true. So, for example, if it is raining and the ground does get wet, then that statement is true. If it is not raining and then the ground is wet for some other reason, maybe there's a water hose or something like that, well, then we still would say the rule, if it's raining and the ground gets wet, is true, because we can't even test that rule if it's not raining, if the it's raining part is false. And so in both these cases, we would still consider it true. So the important thing when you're doing a truth table of P implies Q, which is how this would be abbreviated or symbolized here, we are looking for where there's a true and then a false. That's where we put a false. Okay. So now let's do some of the other related conditionals, which are also conditional statements, and look at the conditions that make them true or false. But we're still going to use this initial rule of where the false is. So let's just look at the converse. Q implies P. All right, I'm still going to start with P and Q. Okay. And when we do our truth table, we're going to have, for two variables, we're going to have 4 rows, because the 4 possibilities is that P can happen and Q can happen, or P can happen and Q cannot happen, or P cannot happen and Q does happen, or P does not happen and Q does not happen. In class, I talked about how this is like having a situation where you have 2 coins and you're trying to see what are the possible things you can get if you toss the 2 coins. And it's like, you can get heads or tails on each coin. So it can be heads, 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 tails, tails, heads, tails, tails. So there's 4 possibilities when you have 2 objects, in this case, P and Q, each of which has 2 choices, in this case, trues or falses. Either they happen or don't happen. So if we're looking at the converse of Q implies P, we're looking this way with the arrow. I'm just still going to write P first and Q second, because at the end, we're going to have P and Q starting every truth table, and we're going to make connections. So I want to keep them set up the same for the purposes of this lesson. So I would ask you, where is the only case? Is it row 1, row 2, row 3, or row 4, where I'm going to put a false because the first thing happens and the second one doesn't? If you said row 3, you are correct, because Q happens. We're doing Q implies P. If Q happens and P does not happen, does not follow, then the statement Q implies P is false, because Q is not implying P, because P doesn't happen. In all other cases, the conditional statement is considered true. Q implies P. Okay, so now we're going to do the next one. That one was the converse because we flipped it around. This time we're going to do the inverse of not P implies not Q. So given the statement P implies Q, we are going to evaluate what not P is, what not Q is, and then what not P implies not Q is. So we're still starting with the same two variables, P and Q, representing our two unknown statements. So P can be true or false. Q can be true or false. Okay, so now we have the four possibilities: true, 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 false, false, true, false, false. If you kind of split it in half with your first row and then split it in half with that, you get your second one. All right, let's talk about how to evaluate not P. Well, if P is true, not P is false. If P is false, not P is true, because every statement is either true or false. So all you have to do to evaluate a not P column is just take the one from P and write the opposite sign of it. So true becomes false, false, true, true. The same is true of doing Q to not Q. You just change the signs. If Q is true, not Q is false. So I'm just switching the signs. Okay. So now we are going to look at the inverse, not P implies not Q. Again, we're doing a conditional statement, which we sometimes call an implication because it has the symbol implies. Not P implies not Q is only going to be false if the first one happens and the second one doesn't. So I can fill that false in right there. The other ones are true. Okay. Last and not least, and then we will make some connections, let's discuss the contrapositive. Okay, so the contrapositive, I'm still going to start with P and Q. I'm still going to do not P and not Q. And if you want, you could switch the order around here. I don't like switching my original variables, but anything I do to them afterwards, I'm going to do not Q first and then not P. So I can do not Q implies not P last. Still starting with true, true, false, false. True, false, true, false. Okay. So now I will do not Q by switching the signs for Q. And I will do not P by switching the signs for P. And now I am ready to evaluate the statement not Q implies not P. A conditional statement is only false if the first thing happens and the second one does not follow. So which row would that be in? If you said row 2, you are correct. A true and a false make a false for an implication statement. All the others are true. So we have practiced doing an implies truth table 4 times now, and we've done it for the original conditional statement, P implies Q. We've done it for the converse of that statement, for the inverse, and for the contrapositive. Now, if you think back to our discussion in the previous lesson, we talked about the fact that if a conditional statement is true, then its contrapositive is automatically true, that they are logically equivalent statements. And we can see here, if we do some highlighting, where the false occurs up here is where P is true and Q is false. Where the false occurs here is if P is true and Q is false. So they are both true and they are both false under the same conditions. That's why they are the same statement. If we look at the converse and inverse, which we already said in our previous lesson, were logically equivalent. All right. The statement, the converse, Q implies P, is only false when P is false and Q is true. Well, for the inverse, our only false is also where P is false and Q is true. So they occur under the same conditions. I don't want to say it's always going to be on the same row. The only reason they're on the same row this time is because I purposely did all my tables with the variables starting the same way. If we had mixed it up a little bit, then it would have occurred on a different row, but it still would have tracked back to a false and a true, matching a false and a true. Even if the false and the true over here were up at the top row, it would still track back to the same variables. So that just helps us show that they are logically equivalent. Okay, so we can say, I will say it here and write it down for you guys. The conditional is logically equivalent to the contrapositive. Remember in class, we mentioned that you can make logically equivalent just like an equal sign with 3 bars instead of 2. That just means that the same sentence, they're going to have the same examples and counterexamples. The converse is logically equivalent to the inverse. Okay. So there we go. So we can see this one more time with a simple example that we discussed in class before. Let's look at the example of if 2 angles are vertical, then they are congruent. The contrapositive of that is if 2 angles are not congruent, then they are not vertical. Okay. Well, if 2 angles are not congruent, of course they can't be vertical because we know vertical angles are congruent. So you can even have a picture for that. They use the same example and the same counterexample if it's a false statement, but in this case, it's a true statement. If we look at the converse and the inverse, if 2 angles are congruent, then they are vertical. We know that statement is false. That is a false statement, okay? Because if we have some angles like right here, corresponding angles with parallel lines, they're congruent, but they are not vertical. All right, the inverse would be if 2 angles are not vertical, then they are not congruent. Okay, if 2 angles are not vertical, then they are not congruent. Same counterexample proves that false because we have corresponding angles which are not vertical, but they are congruent. So we have a case where this happens and this does not follow. So that's just a simple example to try to, show you again in real terms how the statements will be the same, how a conditional statement that is true has a contrapositive that's also true, and how a conditional statement that is false, the converse is false, the inverse is also false, just with a little bit of a real world example. But we did that example the other day when we were doing the other lesson. And remember, these truth tables do not tell you if the statement is true or false. We have no idea what P stands for and what Q stands for. It just tells you, based on if P's and Q's are trues or falses, what conditions would make it false, what conditions would make it true. For every single conditional statement, it'll fall into one of these rows. We just aren't trying to figure out which row it falls into right now. We're trying to figure out what would make it true or false in the world. All right, conjunctions and disjunctions. There are 3 symbols you have to be able to make a truth table for. The first one is implies. We've done that. We know that the false only occurs where you have P happening or the hypothesis happening and the conclusion not following. That is any time that you will have a false. 2 other symbols you have to be able to make a truth table with is the symbol and, a conjunction. It is a statement that is connected with the word and. And then the other one is a disjunction. That is a statement connected with the word or. So a conjunction is with the statement and it is only true if both parts are true. So the example that I used in class was something like, if your parents tell you that they're going to let you go to the movies, that's M, and they're going to let you buy popcorn. Okay. Your parents are only telling the truth if you get to do both things, because and implies both things have to happen. Okay. So when we're doing a truth table more generally for P and Q, okay, it is only true if both parts are true. Now I'm going to start my truth table the exact same way I did at the top of the page, with the true, true, false, false, and the true, false, true, false, to get all the possible combinations of P and Q happening or not happening. True, true, false, false, true, false, true, false. And it is only true if both parts are true. So I am going to say my only true is here. If one thing doesn't happen or both things don't happen, the statement that P and Q both happen would be false. So I'm going to highlight where that true occurs to match up here. Okay, now let's look at or. The word or in mathematics is a little bit different than the word or, let's say, when you're generally given a choice in life, like your parents telling you, you can go to the movies or we can go out for ice cream cones. Okay. Usually when your parents give you that choice, they use the word or exclusively, where you have to pick one. You cannot have both. Okay. Well, mathematics is a little bit different. In mathematics, we use the word inclusively, which means both things could happen and the statement is still true. So if I tell you we're going to have a quiz on Friday or we're going to have a test on Friday, we could have both, and my statement mathematically would be true, but I would be a very, very mean teacher. So I won't do that to you. All right, so we're going to set up our truth table for P or Q. So true, true, false, false, true, false, true, false. The only time an or statement in mathematics is false is if neither part happens. Okay, so that means this is where my false will be. If I give you both things or at least one of them, I am telling you the truth. So there we go. So to summarize here, the implies is only false if you have a true and then a false happening in your table. And is only true if both things happen. And or is only false if both things don't happen. Those are the summary of truth table operations. Okay, when constructing a truth table for more complex scenario, use order of operations. We work inside parentheses first, then we do negations, like we did up here. Where are they? Yeah, we did our roles for negations after that. And then we do conjunctions, disjunctions, and finally implications. So we do conjunctions, disjunctions, and then implications. Now, we aren't going to get too terribly complicated on quizzes and tests, because this is a kind of topic that I want to do, because they are thinking of eventually including it in the SATs and the ACTs and on the state tests. It hasn't happened yet, but they say it's going to happen in the future. And I want you to be able to use this and decide if you like logic, if you might be interested in computer programming or something like that. All right. So let's make a truth table with one variable. We've been doing truth tables with two variables, P and Q, and seeing that the possibilities are 4. Well, if we just have one variable, again, like flipping a coin, there's only 2 possibilities, heads or tails. There's only 2 possibilities, true or false. So when you have one variable, your truth table is going to be so easy. It is only going to have 2 rows, because P can either be true or false. And there's no other second variable to make it more complicated. And then we want to evaluate next negations. Okay, there's no parentheses here, so we can skip over that. We got to look at our negations. We have to do a row for not P. I mean a column. By the way, we've been using this symbol, which is commonly used for negation. Also, I've seen a symbol like that used for it, just in case you ever see it. All right, so remember when we do negation, we just change it to the opposite sign from what it was before. So true becomes false, false becomes true. Because if P is a true statement, like we have popcorn, then the statement we don't have popcorn would be false. If P is a false statement, we have popcorn, but that's not true, well, then saying no popcorn would be true. So that is what we're doing there. And then finally, we'll do P or not P. Until you get really familiar with the symbols, you might want to write the word above it. So remember, an or statement is only false if neither thing happens. Well, if we look here, we don't have a false. So we have at least one thing happening in both cases. So this statement, P or not P, is definitely always going to be true. We call this a tautology when it's always true. You will not be tested on that, by the way. Okay, because it's always going to be true that if you have a statement about having popcorn, that statement, we have popcorn, is either going to be true or it's going to be not true. So, of course, it's all P or not P is always going to be true. So that's the very, very simple truth table with one variable. Now we have a truth table with three variables for the next one. Well, if one variable, I'm going to go write this up here because it's going to connect to what we're saying here. One variable means two rows going across, like this one here. Okay. Two variables mean four rows. Three variables is going to be 8 rows. It's a power of two thing. 2 to the first because we have one variable. 2 to the second because we have two variables. 2 to the third because we have three variables. So how many rows would there be if there were four variables? Which there won't be. Don't worry about that. 16. 2 to the fourth. So a truth table for a statement with X number of variables will have 2 to the X rows. So we know we're going to make a truth table for D and P and C. We always start with the original. I'm just going to use this dotted line thing because I have it. It doesn't have to be dotted lines. It's just what I have handy right here. So we know we're going to have 8 rows going across. So to make my truth table, I'm going to split in half. Since it's going to be 8 rows, I'm going to do 4 trues and 4 falses, because I have to get all the possible true-false combinations for these 3 letters. Then I'm going to split it again, and I'm going to do 2 and 2 and 2 and 2 instead of 4 and 4. True, true, false, false, true, true, false, false. Now, if you want to have the other lines as well, you can. If you can write neat enough without them, that's great. I think on your homework worksheet, I put all the lines for you except for on one of them. Now I'm going to split it in half again. See, first I went 4 and 4. Now I'm doing 2 and 2 and 2 and 2. Now I'm going to do 1 and 1 and 1 and 1, splitting between true and false. That lets me write all 8 possible ways to write trues and falses. So I can have true, 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 false, true, false, true, true, false, false, and so forth and so on. But I don't have to think about them. It automatically generates it if you do it this way. Okay, let's follow our order of operations for these. I have to do my negation next. I have to do not D. And then before I can evaluate this, I need to have a row for this and a row for this. So next I'm going to do P or C. And then finally, I can evaluate the whole thing, not D and P or C. Okay, great. Not D is going to be easy to do this column because all I have to do is take this column and reverse it. So I like to draw little fancy arrows, like just to remind I'm using that. So I'm going to be basically right now, I'm going to ignore all of this while I'm doing this one. So false, I'm doing the opposite. False, true, 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 true. Okay, great. That's done. Now I have to do P or C, which means I'm going to ignore this and I'm going to ignore this while I do P or C. All right, so I'm going to look at, to do this, I'm going to look at both of these and remember that an or statement is only false if they're both false, because at least one of them has to happen for P or C to be true, because it's inclusive or. So I'm looking for where there's two F's, here and here. Everything else is true. It's easier if you look at the one thing, the one rule, because then you have less of them to fill in. Like, this is only false if it's a true and a false. Go fill in the falses and then the rest are true. Only true if it's this, or only false if it's this. Fill in those, and then the other ones are always just the opposite. And you get to kind of do less work that way. You don't have to evaluate them all individually. Okay, now we're going to do our last row. Not D and P or C. Okay, so that means to do that final row, see, I need a color I have not used yet. I'm going to need to look at both of these to do this row, because I have to look at not D and I have to look at P or C. These have already served their purpose. I don't need them anymore. And it's an and is only true if they are both true. So I'm just going to look for where I got two trues. Oh, here we go. Yep, here we go. Here we go. Everything else is false. So we know these three places are the conditions under which this would be a true statement, depending on what D and P and C stand for. So that's the end of that truth table. The last one is where you take a sentence from the real world and we're going to turn it into symbols so we can make a truth table and evaluate the circumstances under which this statement is true. So if it is cold outside, I'm going to let C be that. If it is cold outside, then it is not true that, so I need a negation, we will go swimming and get ice cream. Okay. We will go swimming and get ice cream. So I have turned that sentence into symbols. Whenever it says it is not true that means the other two things go in parentheses. It is not true that everything else I said after that. Okay. If I didn't want it to be the whole thing negated, I would say if it is cold outside, then we will not go swimming and we'll go get ice cream, because then we would only negate the first thing I said instead of the whole blasted thing. All right. So now we're going to design our truth table for this very last problem. We need a column for C, a column for S, and a column for I. And there are 3 variables, which means we are going to need 8 rows. I don't know how far it's going to go across yet, but that's okay. If you like the lines, we'll make the lines. How many do I got? 1, 2, 3, 4, 5, 6, 7, and finally 8. Okay. Now I'm going to set up the rest. Well, you could set up the beginning if you want. We know we're doing halvesies and halvesies. So we're doing 4 and 4. And then 2 and 2 to get all our possible combinations. And then 1 and 1.